Okay, in this presentation we are going to look at confidence intervals. Now this is very much geared towards people who are coming across confidence intervals for the first time. So it's their first time they're meeting this sort of stuff in their undergraduate degree programs, okay? So we have a market research survey. A market researcher wishes to know the market share for Android devices. From a sample of 500 individuals, it was found that 359 use an Android device. Phone. Exercises. What type of data has been collected here? What is the parameter and what is its value? What is the statistic and its value? Calculate a 95% confidence interval and interpret this value. And this is more of a complicated question, so you might come back to this, but we'll just sort of do this here just to introduce the concept of a margin of error. How large a sample is required to reduce the margin of error from the previous confidence interval to plus or minus 0.02. Okay, that one is a bit more tricky than the rest. Okay, so type A, or question A. The type of data collected here, this is categorical data, specifically binary data. So essentially we're asking the people, do you own an Android device? Yes or no. Simple as that. And that is why it's categorical data. So you just have to sort of think about the walkthrough. When you go up to a person, what is the question and what is the answer you are asking them? And what will the answer be that they give you back? Okay? So each individual in the sample either uses an Android device or does not. So it falls into one or two categories. So essentially categorical data is pretty much the answer to that one. Okay. The parameter of interest is the population proportion of individuals using Android devices. Okay. Since we were dealing with a sample, we don't know the true population parameter, so we denote it by P. Okay. Now, just as a remark, in some textbooks, you will see it denoted by the Greek letter pi, which is fine. But we'll just go with P here, just to sort of keep things simple. Okay. The statistic and its value. Okay. So the statistic is the sample proportion of individuals using Android devices. This can be calculated using the following data. So you have a sample size of 500 people and a number of successes, which is the number of people that say yes. Okay. Number of Android users, X equals 359. So we have X equals 359, N equals 500. So the sample proportion, P hat, is X divided by N, which is 359, divided by 500, which is 0.718. 71.8% essentially. Now, the confidence interval. So to calculate a 95% confidence interval for the proportion, the population proportion, we use this formula here. Okay, so we have P hat, which is the point estimate, our sample proportion, plus or minus Z alpha over 2, which is a quantile, which is a critical value from the standard normal distribution. Okay, and it is corresponding to a 95% confidence interval. Okay, and so that's the second part. So there's three parts there: the point estimate plus or minus the quantile times the standard error. The standard error is actually the bit you have to remember here, because that's the bit that changes from question to question. In fact, the Z score, Z is the critical value, that actually stays very consistent around from question to question, and you will see this number 1.96 pop up a lot. Okay, but anyway, the standard error, the square root of P hat times 1 minus P hat divided by N. Okay, P hat again is our point estimate, 1 minus P hat is the complement of the point estimate, and N is the sample size. Okay, that is part of the question. That formula is often given in the back of an exam paper, so just look out for that. Check your past papers just to see if that is given there. Okay, so using these values, we have P hat, which is 0.718, N is 500, and we have our quantile, Z, alpha over 2, which is 1.96. Okay, so I'll just look at the standard error first off. That is P hat times 1 minus P hat divided by 500. So that is 0.718 times 1 minus 0.718, which is 0.282. So we have 0.718 times 0.282, divide that by 500. Okay, then we're going to get the square root of that. So we get the square root of 0.000400456. Now, I advise going to several decimal places here, 6 or 7 at least. There's actually 8 there. I didn't keep track. But anyway, to get the square root of that, and we get approximately 0.0201. Okay? So, you just notice there that is, yeah, I'll just keep going for that. So the margin of error is the quantile. It's what we collectively term the quantile times the standard error. So it's essentially the point estimate plus or minus the margin of error. Okay? So in this case, our margin of error is 1.96 times 0.0201. And our 95% confidence interval is the point estimate plus or minus the margin of error. So that is 0.718 plus or minus 0.0394. And we get a confidence, 95% confidence interval of 0.6786 to 0.7574. So we're 95% confident that the true proportion of individuals using Android devices lies between 67.86% and 75.74%. Now we look at the last part, which is looking at the margin of error and the sample size. Okay, so sample size to reduce the margin of error to plus or minus 0.02. To find the required sample size n to achieve a margin of error of plus or minus 0.02, we again look at the formula for margin of error. That is the quantile, the z-score, z of alpha divided by 2, times the standard error. That is the square root of p hat times 1 minus p hat divided by n. Okay. What we're going to do here is do a little bit of algebraic rearrangement. So what should happen here is if we square both sides and rearrange them algebraically, what we end up with is n equals the quantile times the standard error divided by the margin of error and square that. Okay. Now it looks quite tricky looking, but remember we have a lot of set values here, so we just have to use a lot of these set values. Our z quantile is z of alpha over 2 equals 1.96, p hat equals 0.718, and the margin of error is 0.02. So essentially, when we put all of these numbers in, things start to resolve fairly quickly. So n is 1.96 times the square root of 0.718 times 0.282, that's the 1 minus p hat, divided by the margin of error, 0.02, and we get that expression and we square it. So it's 1.96 times 0.533 divided by 0.02 to be squared. Okay, that is 52.2296 squared, and that should be 2728.02. Now, you'll notice there's a little fraction. What do you do with that? Do you round it down to 2728? No, because that will bring you back in just over a margin of error of plus or minus 2.02. So essentially, what you have to do is when you get a number like that, you have to round it up. Okay? Bring it up to the next integer. Okay, that's the important bit here, really. So it's important that to increase the sample size in this sort of situation. So rather than round it down, what we do is we round it up to 2729, because that will mean that the margin of error is just less than plus or minus 0.02. So it's narrower than plus or minus 0.02, whereas 2728 is just that little bit wider than plus or minus 0.02. Okay, that's important. Okay, that's it. We'll leave it there.